And hello everyone, and thank you for joining this LINSTOR VSAN's launch webinar. As Will mentioned, this is Yusuf Yildiz, and I'm working as a solution architect in LINBIT. And I'm going to explain some of the basics of DRBD and LINSTOR in this slide. It will take roughly 20 minutes, maybe a little bit less than that. Please feel free to interrupt me during the presentation if you have any questions. And after this presentation, our engineer, Christoph, will give you a short demo about LINSTOR vSAN and how it's working on a VMware environment. Before starting our slides and the products, let me give you some details about LINBIT. LINBIT is an open source company based in Austria, Vienna, and we have another office in Portland, Oregon, in USA. And our CEO, Philipp Reisner, founded the company in 2001, and the company is in service since then. Although our products are open source, we offer support packages for those who need it. To provide such support 7/24, we have a team of engineers in both offices in Austria and also in USA. Apart from these offices, we have partners all over the world. And in Japan, we have an exclusive partner called CIOS. Our product is called DRBD, which stands for Distributed Replicated Block Device, which is basically doing block replication in distributed platforms. And DRBD is embedded in Linux kernel since 2010, so it's not hard to find in your Linux setups. Our go-to-market is mainly 3 products that I can mention here. One of them is LINBIT Disaster Recovery, and LINBIT Disaster Recovery, which is combined with DRBD and DRBD proxy if needed. And we have LINBIT HA. LINBIT HA is a stack of DRBD and pacemaker. And another one that we called LINBIT SDS is combined platform of DRBD and LINSTOR, which is our main focus today. And everybody loves DRBD. And I'll make a confession here. When I first joined LINBIT, I didn't know that DRBD is such a popular replication tool in Linux world. And whoever I talk about Linux systems after that, I learned that they use DRBD at some part of their lives, or they are currently using it, and they just love the product. And over the time, I realized that this love and interest is not because we are a very cute company, but because the product is based on a very solid ground. And our team has spent the last 20 years on a block device replication, and is specialized in this area, actually deserves this attention. Let's move to DRBD and give you a little bit information about that, and then I will go into the LINSTOR. So you can think DRBD just like a target and initiator in a different way. In this time, the target is another disk in another machine, which we called secondary, and the initiator is a primary disk on a primary server on DRBD world. It's like a RAID 1 array over the network. In LINBIT, we called this pair as a primary node and a secondary node. We are doing replication from primary to secondary or secondaries. If something happens on the primary application, let's say you have an SQL, you can basically stop the application on primary, unmount the file system, mount it on secondary, and then start the application from there. And this is just for DRBD. I'm talking about DRBD, not LINSTOR. And DRBD on 8th version was a 2-node technology, but thanks to DRBD 9, we are now supporting 32 replicas in one pair. And we know that one of our customers are using a LINSTOR cluster with 496 nodes in 1,430 volumes in the single setup. So, and it has 1 petabyte of available data inside that pool. So I just give you this example to show you how it can be a bigger version of this. And what happens if you lose disks on primary, right? Actually, nothing in the RBD world. A primary node can reach other nodes and keep going without any problem. And you can use primary just like a load balancer. And this scenario actually is not occurs only when the disks are failed. You might want to use some cases like this, just like I mentioned, the load balancing and so on. And we have a technology called change tracking bitmap in each node, and the primary, if doesn't have any disks, it don't have any change tracking bitmap, and the change tracking bitmap is located in secondaries, and they always stays updated between them. And here are some features about DRBD, and there's a lot, but I just put 5 of them in here. And CTB, just like I mentioned, is called change tracking bitmap, and all the nodes knows the version of the data in case of something fails. And what it means here, the CTB on each node, and we are keeping up the data for change blocks on the each node itself, and it gives us a great flexibility. And another feature is partial resync. If you have an outage on one node, or maybe network is lost, and that's not a problem for us. When the node becomes online, it automatically resyncs where it left, thanks to the CTB. And the split brain, right? Everybody was afraid of that. And we have mechanisms for preventing split brain problems. While fencing is not a fancy thing to use, our recommendation will be always go with the quorum setup. This setup will need at least 3 nodes in the cluster, right? To provide a quorum. And another feature is to verify the data, and our verify and resync times are really fast. The verify and resync mechanism is based on the checksum. And when it comes to the resource count, you can basically have thousands of resources per node in DRBD. And remember the customer I mentioned you about the DRBD, the big one. And this is our roadmap in this year. We have a feature upcoming called evacuate. And if you have a node that you will want to gracefully take down for whatever reasons in your cluster, before you do that, you evacuate that node, and that will migrate all the resources from that node to other nodes. It will take some time, maybe it will take some hours, days, it depends on the resync speed and your configuration, but eventually it evacuates all the active data from that to the other nodes. And we have a Kubernetes operator upcoming. Lately, we finished developing it for LINSTOR, and you will be able to use it soon in your Kubernetes environment, and it will really help you to manage your persistent storages in your Kubernetes. We have another feature called snapshot shipping, And for replication over long distances, we know we are using a synchronization method right now in DRBD. But in some particular cases, we know that this is not a convenient at all, because a lot of things are getting in the line: the bandwidth quality, the write speeds, read speeds, routers, everything is involved in that kind of replication. So we are currently developing a snapshot shipping feature for solving this low bandwidth, high latency environments. And VMware appliance. Our main focus today. The appliance is almost ready to use in the enterprises. Right now, I hope Christoph will give you much more detail about the versioning, but as far as I know, it's now 0.9 version, and it's close to a stable one. And multi-tenancy, right? Because multi-tenancy is a must in shared environments or in service providers. So we are developing this feature in LINSTOR for better maintaining such environments. And in late 2020, we are planning to launch DRBD 10, including erasure coding and a lot of disaster recovery improvements upcoming. And we are expecting to finish all of these in 2020, hopefully. And VMware. Everybody loves VMware, right? Because by far it's the most common hypervisor in the market. Therefore, in LINBIT, we also think that is a good idea to implement our beloved LINSTOR into this VMware world to provide hyper-converged environments in any type of servers. Let's try to understand a little bit more about LINSTOR and VMware, what we call LINSTOR VSAN. So the product we called is LINSTOR VSAN. So it supports two-way, three-way replicated volumes inside of these VMware environments, and you will have high availability without having a split brain in your cluster. It supports for iSCSI targets currently, and you can provision 10 volumes in your environment, so you don't have to allocate all the storage you have. That will give you some area to work on your storage. It supports the application, and you will have a fancy dashboard, web dashboard to maintain your disks, create disks, and iSCSI exports, bind them in the VMware, and etc. And also, I know when it comes to LINBIT, everything is in a high performance side, and LINSTOR VSAN is not an exception of that, because it relies on DRBD replication and all the technology we have. And everybody knows that we hit the world record with 14.8 million IOPS. And it's also open source based OS, open sourced OS based, which is CentOS 8.
Hey, Yusuf, I want to ask you just a quick question. What about NFS support?
NFS support is a thing that we are currently also developing. I don't know if it's the case for LINSTOR VSAN, but it will definitely come for the LINSTOR. LINSTOR, we will have the NFS support in, I don't know, a matter of weeks. That's up to the engineering team, but maybe in also VSAN. Maybe Christopher also give us some details about that in the future. And that was a great question. Thank you. So, LINSTOR basically orchestrator for disks inside your Linux machines. You can easily provision, migrate, delete volumes in LINSTOR with some simple commands or web GUI, or with the help of the great API that we developed. And in LINBIT, while we're developing LINSTOR, our main focus was the SDS customers like VMware or cloud native applications, or Kubernetes, OpenStack, OpenNebula, and etc. This is what we were focusing on. And it's built on the existing Linux storage components, and it gives you the comfortable zone to play with. So you're not having hard time to understand how it works and so on. It's really easy to implement, easy to understand, and easy to work with. And multiple tenants is possible in the future, like I mentioned in the roadmap, and it's coming. And one of the main advantages of the LINSTOR is to use distinct storage nodes in one cluster. Because LINSTOR is not vendor locked in, and it gives you this great feature. You can use NetApp or HP or Dell in one cluster, and we don't care about that. The thing is, we are looking for the block devices. And it's also suitable for creating hyper-converged, obviously, we will see in the demo. And you don't need to use DRBD with LINSTOR, actually. DRBD is not a must for LINSTOR. If you are handling the replication with some other way, I don't know, in the storage, in the node itself, that's up to you. You can just skip the replication part with LINSTOR. You can just use it as an operator, orchestrator for your disks. And one example of this kind of situation is with the Intel case. And Intel has one big rack consists of 20 servers, 4 storage nodes to provide object storage with MinIO. And the LINSTOR was the backend who provides disks to the MinIO. And doesn't use, in this setup, doesn't use any DRBD and so on. Just creating volumes, deleting, managing the system, and etc. All right, let me try to explain a little bit about the architecture of LINSTOR and the small functions. So in here, you can see a small example of LINSTOR architecture a little bit. And we have LINSTOR satellites and controllers, and each part of the LINSTOR is definitely independent from each other, and what we call stateless. And so there will be no downtime if you reboot, upgrade, or just close the LINSTOR controller. It doesn't matter. You can just close it, make your maintenance, open it, just move it to another node. That's up to you. And it's embedded an SQL database, but you can put that database into an external SQL. That's up to you. And also, we have a great API library for connecting this great piece of technology to OpenStack, OpenNebula, OpenShift, Kubernetes, and also a VMware. And you also have a CLI if you want to play with it or just manage your LINSTOR setup with CLI. That's up to you. And this is pretty much it with the architecture. So we have controllers on each system, and it can be HA with DRBD, with using the pacemaker also. And we have satellites for each node for maintaining the disks and using them. And LINSTOR controller is talking with the satellites, creating disks, removing disks, moving disks, and so on, or replicating disks and so on. All right. I'm sorry, I think I passed one. No, okay. So let's say you have a hyper-converged hypervisors. With each of them is a LINSTOR, has a LINSTOR satellite, right? And each VM disks is relying on one local disk and one distant replica. You can manage, you can create this kind of policy in your environment, and this gives you an advantage of writes to the local and remote disks. That means your network overhead will be on the write operations, but reads from the local only. This is important for data locality. And we know if you distribute data across the cluster, network always give you some bottleneck problems. Your switch can be a problem, your cables can be a problem, and etc. and etc. And this is a troublesome an issue. with LINSTOR, so there won't be any overhead on reads, which is more important on like 99 cases, 99% of cases. And in this scenario, let's assume that we have a policy with each VM has two-way replica in the cluster. When you move the VM to the another host for some reason, that's up to you, VM loses the advantage of data locality and starts reading from the network all the time. So we had a local copy, now we don't. We are now reading and writing from the network, just like I mentioned. So with a time-triggered policy or a manual command that you can initiate, a LINSTOR to create a third replica inside of this new host. But right now, you have 3 replica instead of 2. And LINSTOR will delete the third replica in one of the other hosts. So system basically stayed in the desired state, which is 1 local disk and 1 local replica in all other hosts. And these systems and scenarios can be a lot, but let me give you 3 more examples about LINSTOR vSAN, and then I will pass the presentation to Christopher. So in this scenario, this is a small configuration for LINSTOR vSAN. You basically have 3 servers, 3 nodes. 2 of them has a local disks, can be SSD, SATA, whatever. And the third one is just there to provide quorum. And VMs are replicated through network with 10 gigabit switches. And you can even move VMs into the diskless third node if you like. So VMs are basically using the data stored in these 2 nodes. And you can move the VMs to third node, the diskless one, which is there for quorum, but let's say you have enough CPU and memory inside of that third node, you can move the virtual machine to third node and you can still access the data store in these 2 nodes. So let's say you want 3-way redundancy, right? It's actually same as the small configuration that I just showed you, but this time you have disks in all servers instead of 2 servers, 2 nodes, and this will give you the power of 3-way redundancy for your valuable data. And I'm expecting actually this will be the most common case for LINSTOR vSAN in the future, and people tend to use these kind of setups in their small VMware environments. 3, 4, maybe maximum 5 of these nodes. And here is another simple example of LINSTOR vSAN of consisting 4 nodes relying on two-way redundant data store in here. 2-way here, 2-way here. As you can think on this example, you can actually expand this LINSTOR vSAN appliance up to 16 nodes in a single cluster. This is the theoretical limit right now. And I believe it will be much more than that in the future. And I finished bothering you with the slides with this final summary page. And you can clearly see the LINSTOR structure and ecosystem in here. We know it's hard to maintain and manage storages in every system. We know because we are doing this, we are developing this technology for over 20 years. We have a lot of experience on this, and we know it's, therefore, that's why we developed LINSTOR actually. All these layers of storage area is maintained by LINSTOR itself, just for you, so you can focus on expanding your products or service or your environment. It's up to you. And thank you. I finished my slides, and now I'm passing the presentation to Christoph. Christoph?
All right, Yusuf, thank you very much for that overview.
You're welcome.
Yeah, and I will just quickly demonstrate what that would look like, a LINSTOR VSAN deployment. So I'll just share my screen here. I hope this is working.
Yeah, it's working. We can clearly see it. Don't worry.
Perfect. All right, so what I have here in front of me is a VMware ESX server, which is basically just a single node of a VMware cluster. And what I have here is I've already prepared 3 machines. The way this works is you get an OS image from LINBIT and just import it into your VMware server and just start up the machine there. We can also see in the preview it's just a regular CentOS system. We get this introductory screen here, like just on the console, and we see that it's giving us an IP address. And if we just navigate to any of these IP addresses, which I've conveniently already done, we get to the setup page. So the entire setup is web-based. It's important to note that this vSAN thing isn't really a new technology by itself, but all the things that Yusuf described right now, which are normally pretty complicated to set up, just can get set up with literally the press of a button. All right. So the first page we have here is a login page. This authorizes you with LINBIT's services, which is the mylinbit.com service. We have prepared the little test account here. And we'll just log in. Now we can choose a contract. So ideally you'd already have a contract with LINBIT where you like kind of register, store the nodes. So what it's doing now, how this works is, I mentioned already that I have 3 machines here running in parallel, and they're all on the same network, so they can auto-discover each other. So this is a pretty useful feature because you don't want to like manually search all the IP addresses and enter them in tediously. You can just, it scans here your network and it discovers all vSAN nodes that it finds on the network, and you can just configure them all at once. So here, obviously, I want to configure all 3 nodes. You need to have at least 3 nodes, as Yusuf already mentioned in the overview. So let's click continue. Now we have to choose a name for our cluster. I'll just make it file server to store all our files. Yeah, and what it's doing now is, I mentioned before that we had to log into mylinbit.com. Now it's registering these 3 systems with LINBIT so that they can receive updates and LINBIT software, which will now be installed. So what this basically does, all the things Yusuf just mentioned, DBD, LINSTOR, Pacemaker, all the high availability software is now installed to the systems. And this is just going to take a little moment.
Christoph, we have a question.
Sure.
Brian asks, during the network scan, does it scan once or continually scan and loop the process?
It continually scans. So if I were to add a node right now, or not right now, but before on the scanning screen, it would detect the node and I could just set it up with 4 nodes. So that's no problem.
Okay, thank you.
Thanks for the question. All right, updating is almost finished. So now, like I mentioned, it's installing the LINBIT software from LINBIT's customer repositories.
Christoph, while it's loading, I want to ask real quickly, what operating system is this solution based on?
Yeah, so this is as I think Yusuf already said before, it's CentOS 8, so Red Hat open source Linux kind of, and it's like state-of-the-art, like the most current enterprise Linux open source solution out there.
Thank you.
So I guess while this is loading, I can talk about the solution a bit more. We've almost exclusively spoken about it in the sense of VMware, but this can also be used in a lot of different environments. For example, we tested it internally with an Oracle VM cluster, and it works just as well, but it's of course targeted to VMware deployments. So yeah, our software is installed now, so we're ready to set up our cluster. So the next step, this will happen relatively quickly. This will set up all our services. So like I said, everything Yusuf talked about before will now be set up in the click of a button. So now Pacemaker has just started, which provides us with the high availability part of the concept.
Yeah.
Now we're just waiting a little bit for LINSTOR to start up, and all right, there we go. So that's basically a complete software setup, high availability, software-defined storage stack setup. So now that the tools are set up, we can start actually using them. I actually added a disk to all of these VMs beforehand. It's not very big, but for the purposes of this demo, it's going to be enough. And we see that it is deployed on all 3 servers, right? So we have a 16 gigabyte disk in all of these servers. Ideally, it's the same disk, of course, or the same type of disk and the same size. So we can just select we want our disk on all of them, so we can have up to 3 replicas of our data. Let's call this pool SSDs because it's an SSD. We have the choice here of choosing regular LVM volumes, or thinly provisioned LVM volumes, or VDO, which uses deduplication. Of course, LVM uses the most storage, so it's more or less the least efficient in terms of storage, but it's also the fastest. LVM thin is a trade-off, which stores it more compactly, but is also a little slower. And VDO stores it very compactly, and is the slowest of these 3 solutions. So we kind of give you the choice what solution you want to use here. Yeah, so let's create that storage pool. Great, we have it deployed on all 3 nodes now. Let's continue. Now we need to set up a resource group, which is a concept that comes from LINSTOR. Basically, it's like a deployment template, right? So you choose what storage pool you want to deploy the data in. You choose how many replicas you want. In this case, 2 replicas is fine, and the storage pool we just created. And we just have to give it a name. Let's call it 2 replicas. And once we hit continue, this is kind of the beef of the whole thing. It's the main part. This is where you configure your iSCSI targets. So, for example, I can just do a quick example here of some LINBIT domain. Let's call it file server. And we have to choose a service IP here, where the iSCSI target will always be available. So it, in case of a failover, it would get passed to the next node, and it would then be reachable from there.
Christoph, can I interrupt you?
Sure.
I know this is only this LINSTOR appliance right now only provides an iSCSI target, but we know this is not just for VMware. You can also use it for Oracle VM environment and so on. But this is not only a VMware solution. And the first question is, can we just use it out of the box in the other hypervisors? And the second question is, when we develop LINSTOR NFS, will be a web GUI for the NFS exports?
Yeah, great question. NFS support is, like you said before in your introduction, is planned for LINSTOR at least, and I guess I can't speak for official support, but if it works well with LINSTOR, which we expect, it would make sense to also have it in LINSTOR VSAN. And sorry, what was the first question? I didn't get that right.
The first question was, can we use this LINSTOR appliance in other hypervisors?
Yeah, of course, yeah. Yeah, so like I said, we did some kind of unofficial testing with an Oracle VM server, and it worked just fine. You can use it on bare metal installations. You can use it in, I don't know, KVM installations, Proxmox, everything that that can provide or that can run virtual machines, or actually everything that can run an operating system can be used by that.
Thank you.
Yeah, so we'll just quickly assign a username and password for the iSCSI authentication, and we can, you notice, we can here choose the resource group that we created before. So this is just a small example, so I'm not overdoing it, but you can have like categories here. You can have slow storage on hard drives with only 2 replicas for maybe not so important data. You can have 2 replicas or even just 1 replica on SSDs for very fast storage. We can have 3 replicas on HDs, and the list goes on. You get it, right? It's you can like define storage classes here using these resource groups. But right now we only have 1, so we'll create it here. So in the background, this will create a LINSTOR resource, and it's already done. So this is now basically a complete DRBD setup, which is accessible by this service IP that we defined, right? So let's try to use it from VMware. It's and actually another note here is that this doesn't have to be a VMware consumer, right? So the initiator to the target is basically anything that can consume an iSCSI target, right? So we have our software iSCSI adapter here. And if we just enter our service IP here and save the configuration, you can see here that it discovered the target, and we now have just a regular iSCSI target that we can use to define data stores. We can create disks, use them in VMs, run VMs on it. So obviously this is a pretty powerful solution. From here on out, it's just like everything your imagination or you can imagine you can do with this target. So yeah, it's a pretty powerful solution. And that concludes my demo. Thank you very much.
I want to ask a quick question about migrating from one ESX node to another, how that works.
Yeah, like I said, this is just like a small demo example, but if you, like obviously in a real world, you would have a much more sophisticated scenario, right? So you would have like a vSphere server on top and maybe vMotion to migrate these machines. And basically how it works is normally you would have one of these machines on each hypervisor, right? So if the hardware fails on one hypervisor, it gets migrated to another hypervisor, and then the whole system is up and running again. So Pacemaker will take care of that. If one of these 3 virtual machines goes down, it just kind of shuffles some things around and it's working again. And if the third node gets back online because it gets migrated, it will work just as before with 3 nodes.
That makes sense. And what about how much Linux knowledge is required to operate and maintain this?
Yeah, so this is also a great point. Thanks for the question. It's a great thing about this is that you need almost no Linux knowledge, at least for the initial setup. Like everything I just demonstrated is basically everything you need to get it up and running. Obviously, support is another question, and things can go wrong. That's no question. But for the initial setup and basic maintenance, it's no Linux knowledge required. And actually, I forgot to show something very important. I just thought of it because of your question. Thank you. We also have a small dashboard built in. This is just really basic. Just kind of displays our 3 nodes here, right? And the status, which is green, everything is okay, and red is something is not okay. So another option we have here is to put the node into standby. This would mean that all resources get moved away from this node. And that's about as much control as you get here. And that's kind of on purpose because it's really meant to be as simple as possible. Like I said, you don't have to have any knowledge. So yeah, that's the basic idea.
Thank you, Christo. One more question from Walter in the chat. He's asking, is Red Hat Rev supported or SUSE, KVM, or Zen?
Yeah, like I said, basically everything that can run a virtual machine is supported, and everything is supported as a hypervisor, and everything that can consume an iSCSI target is supported as a initiator, right? So it really doesn't have any restrictions. Obviously, we can test it only on so many different systems, right? So we can't guarantee that it will work straight out of the box for everything, but it should work straight out of the box for any given hypervisor.
Okay, cool.
Thanks for the question.
Thank you for this great presentation for LINSTOR
Thank you very much.
appliance. We are really looking forward to this stable version. Do you have any kind of roadmap for that? So what is the current version of it? When will the stable release is released by the LINBIT?
Yeah, so what I just demoed here is a version 0.6, which really doesn't mean anything. It's just like a preview version, so it's not really ready. You also notice that it doesn't actually say VSAN anywhere. That's because this is just really kind of a development version. Like it works and it would technically be production ready, but we haven't released it yet. So I can't like promise a fixed date, but I think beginning of Q3 2020 is very realistic for a first customer shipment. I don't want to make any promises here, but that seems very realistic to me. And actually, in the next few days, we'll actually release a version 0.9 of LINSTOR VSAN, which will include one more feature, which is adding and deleting nodes from the cluster. And that's called 0.9 because we want to make it clear that it's like really close to being finished. So we have since had a few discussions with customers about it. We have showed it to a few people, and we have collected many great suggestions from them, and we will implement them. And then, as I said, like end of Q2, beginning of Q3 2020, we are expecting to have somewhat a final release, which is customer ready.
Okay, great. So, in the attendees, do you have any questions regarding to the LINSTOR VSAN? Anyone? All right. I think we are finished this presentation. And thank you for joining LINBIT's LINSTOR VSAN webinar with us. And we will be sharing this webinar in our social media accounts and also in the website, so you can rewatch or share with your colleagues if you like. And I hope, and I know that we are going to do webinars in each month. So please keep in your mind that each month you will have a LINBIT webinar for the products we have, for new releases, for new kind of features and so on. So thank you once more, and watching me, Christoph, Will, and everyone, and have a great day, great week ahead, and stay safe, stay healthy in your countries. Thank you.